Hello everyone, welcome back to freepilotgroundschool.ca. This is the first lesson of navigation. So hopefully you believe me and you're still with me when I said at the beginning we're going to start with the boring air law stuff and end up with the practical stuff. Obviously learning how to navigate an aircraft is very important. It's very practical. You do it on every flight and obviously it's pretty embarrassing if you end up getting lost. So let's get started with some definitions. Just so this will form a basis for the rest of your lessons in navigation. So a couple types of map. The transverse Mercator projection is in visual terminal area only. A straight line is a rhumb line. The Lambert conic conformal projection is used for the VNC, so a scale of 1 to 500,000. And a straight line is a great circle. There's also a map we didn't talk about, the WAC, the wide area chart. That scale is 1 to 1,000,000. Never seen anyone use them before. They're just like these massive maps. They're used for high speed, high altitude VFR navigation. I don't know who flies VFR at high speed and high altitude. So I think they're still made, but never seen one, but they're found in some textbooks. Quick review, each 15 degrees of longitude equals 1 hour of time. So that's 360 degrees divided by 24 hours a day. In the Western Hemisphere, add the time zone difference to determine UTC. So if we take the true track, we add or subtract the variation, we end up with the magnetic track. We add or subtract the deviation, we end up with compass track. The calibrated airspeed is found in the POH. True airspeed is calibrated airspeed corrected for air density. We can look at the POH to find our planned true airspeed. Then we look at our flight computer if we want to convert our indicated or calibrated airspeed to true airspeed based on the temperature and pressure. Ground speed is true airspeed corrected for wind and is the actual speed over the ground. Just a quick review, the route selection factors, weather, terrain, fuel, and water. We have to have the AeroJIP documents on board. And then the rest of this lesson, I can't really review very well because, well, it just requires a lot of practice. But here you go for your review, some things that you need to think about. You have your set heading point here in Kakabeka Falls. That's where your navigation officially starts. You're going to fill out your VFR flight log, distance you measure, track you measure. Then you're going to look in your pilot operating handbook for your true airspeed. Look online to get your your wind velocity. Then use the backside of your flight computer to figure out your ground speed and true heading. Correct for variation to get your magnetic heading. And then when you have your ground speed and your distance, you can figure out the time en route and the fuel required. You're going to look at your fuel flow in your pilot operating handbook, both the climb performance and the cruise performance. Also going to pick a couple or a few checkpoints to fill out your en route log, and your distance flown is the distance from the set heading point. And we're going to discuss in your next lesson how you're actually going to use this en route log when we talk about in-flight navigation and the work we're going to do in the air to figure out our revised estimated time of arrival. Lastly, in-flight navigation at the set heading point, you want to start the time, set heading indicator, do an engine check, departure angle check, and open the flight plan. The en route checkpoints, you're going to mark the time, calculate the ground speed and revised estimated time of arrival with your flight computer, set the heading indicator, do an engine check, and a position report. The double track error method is used before the halfway point. You correct double the degrees off course and fly for an equal amount of time since your set heading point. The opening and closing angle is used for drift correction after the halfway point, and you add the opening angle and the closing angle and correct the angle. Return to departure, you just turn 180 degrees around and fly double the wind correction angle. Lastly, the 1 in 60 rule means that if you're 1 nautical miles off course in 60 miles, that's 1 degree, and therefore you can do the ratio. That concludes navigation. Thanks so much for bearing with me. We have one more lesson left, and then we are done ground school.